Question number 14, we've got a Venn diagram here. It looks like one counts for basketball, the other's for computer, and then we've got this in the middle here. It's nice up here in the information, they tell us we've got 16 students, and so we know the total number. They also tell us that there is one student that is not in either of the student clubs. That's not that. Yeah, Yolanda, that was up here. Yolanda's outside. And then what it's going to do is it asks us that one student will be chosen at random, selected with the A denoting the event the student is in the basketball club, B denoting the event is the students in the computer club. So let's find these. So what's the probability of A? A is the students in the basketball club. So we know there's a total of 16. And they want the answers as a fraction. That's always a good thing to get out of the way, to figure out. So we know it's over 16, and how many are in the basketball club? That's probability A. So it's just 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 16. I don't like that 9 very well. So let me see if I can write the 9 a little bit better. How's that? A little bit better. Probability of B, and B is the event that a student's in the computer club. So these ones in the middle are also in the computer club, so we count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 16. Probability of A and B. Now remember, this and is an exclusive and. They have to be in both clubs. If they are not, they're excluded. So that excludes these folks here, and of course Yolanda's not in either one. So the only ones that are in both are here in the middle. And there's 1, 2, 3, 4. And the probability of that would be 4 over 16. And notice I'm going to come down here. I see I got this equation. It's going to be helpful for me that I did not reduce any of these fractions. One of them I can't, but two of them I could have. Probability A or B. Now remember, I'm going to have to come back here and get rid of some of these. Probability of A or B means that they're in either of the clubs or both. So actually all of these in here are going to get counted. And I could count them, or I could just say, well, there's 16. It's everybody but Yolanda, so 16 minus 1. That's going to give us, I'm going to write it out over here just to, it's going to give us 15 out of 16. Okay. And then we've got this formula here, probability of A, and let's just do it down here. Probability of A, we calculated that as 9/16. Probability of B is 10/16. Minus the probability of A and B, because that's the overlap. That's ones that we counted twice if we're going to do this. So it's minus 4/16. So 9 plus 10 is 19. Minus 4 is 15. 16ths. And what does that equal? Well, there's 15/16 here. That's the probability A or B. And so we come down here and we choose this probability of A or B. That's what that formula gives us. Yeah, the total. Taking away the ones that would have got counted twice. Number 14, we'll stop it here and move on to 15.